Okay, so this is video assignment 3 for organic chemistry. So the first task was to distinguish between a strong base and a good nucleophile. And so I said bases, what they're known to do is they take the hydrogens or the protons. And so an example of a strong base would be O to H right here. That would be a strong base. We see that both nucleophiles and bases, a similarity that they have is they're both going to be electron rich. So a key difference to tell between bases and nucleophiles is bases are going to be a smaller atom that overlaps, while the nucleophile will be a much larger atom. So an example of a nucleophile is SH. So I kind of drew to help illustrate. The sulfur is going to be much larger than oxygen, which if you look at a periodic table of elements, you'll see sulfur is considerably bigger than an oxygen. So those are some similarities and differences to determine between a strong base and a good nucleophile. The second task was to tell the mechanism of a problem. So I was tasked with this, and right away looking at this, I can tell based off the bromine right here that it's going to be primary. I can tell that because there's going to be the bromine's going to be the leaving group, and it's going to be attached to only one carbon, because here it's attached to an oxygen. So attached to one carbon means it's going to be primary. This means we can basically eliminate SN1 and E1 mechanisms. And so we know that there's going to be heat as well in this reaction, which heat generally favors elimination. So if we're going to do elimination, we know that we can just circle the leaving group, and we can circle the hydrogen down here because this is the nearest carbon to it. And we know this is going to come in. So we'll go down here. So I'll draw a little arrow to help illustrate where we'll be going down here. Down to one hydrogen. And just the hydrogen up here, because the bromine and the hydrogen are going to be gone. And so we know here it's going to be H2O. That's because this is going to pull this hydrogen. It's going to I'll draw an arrow to help illustrate. It's going to go down here and pull this. Well, the bromine is just going to bump itself off. And so that's going to result in this, which this turns into a carbon, double carbon bond, and it's going to be hydrogen, or water. And we also know the bromine's going to be gone, so it's going to be Br minus. And so our final products will look like this. That plus the H2O and the bromine, which is going to have a negative charge to it. And so overall, this is going to be E2 mechanism. And that's about it. Thank you.